Welcome to my Commodore 64 Games memories. This is where I look at old games and some of the technical details behind them. Let's get into it. Today we have Jack the Nipper 2, published in 1987 by Gremlin Graphics. Concept by Greg Holmes, coder Andrew Green, and graphics by Terry Lloyd. And of course musicians were Ben Dalglish, Dave Pridmore and Greg Holmes again. This question was asking how a single load game can have such a large map, so let's get into it. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. First thing to notice is on the title screen we have the sprites up at the top for the Jack the Nipper 2 logo. We can see the sprites in C64 debug GUI outlined in those red boxes, and we can see that we actually have the game scrolling split there with the score panel using a different character set compared to the main character set used for the title screen. Now we have inside the game we seem to have some of those sprites in the same position as the Jack the Nipper 2 logo from the title screen, but they seem to be blanked out with blank sprite definitions. The way that the game is leaving behind these sprites kind of tells me that the game doesn't seem to use a multiplexer, or at least the multiplexer is just it's just leaving the previous sprite positions just sitting there. The split itself between the scrolling section up at the top and the static section for the score panel just looks like a standard kind of screen split. Nothing really too special about that at all. If we go to the nice expanded screen view in C64 debug GUI and move around, we can see that some of the sprites, even though they've got blank definition or empty definition, or empty frames rather, they kind of like move around with the scroll. Now the question did ask what goes on in this transition, and we can see straight away that actually just the sprites and stuff like that continue scrolling around during that transition, but the multicolors and stuff change, of course. The extended character colors actually, well, the multicolor extra color definitions change. The actual screen character colors don't seem to change at all. Running around, this game doesn't seem to be too sprite hungry, does it? I mean, there seem to be quite a lot of sprites, but it doesn't ever seem to go over the 8 sprite limit. There's quite a lot of color variation between the sections on this map, but that's due to the fading in and out. Note the screen color and the extra multicolor for the screen characters fade in and out as the map goes between this transition area. If I force the color now to be white and then go through the transition area, you can see that nothing really special happens on the screen. The screen just scrolls as normal. Everything would be black, but I forced one of the multicolors to be white by using the C64 debug GUI feature there for forcing the color or the register value to be a specific value. So we can see actually there's just the sprite multicolors and the character screen multicolors just fade in and out between that transition between the different colored areas on the map. Let's look at this now in ICU 64. And here we are in ICU 64 with the graphics map for the sprites view there. Well, okay, we found where the sprites are in the second Vic Bank at 4000. And there seem to be some last sprite definitions as well. 8 sprites, looks like it. 1, 2, 3, 4, 5, 6, 7, 8. Yes, looks like 8 sprites up in the top of memory as well. I'm guessing that they get swapped over between the title screen and the game. We'll test that hypothesis later on. We can see that we've got what looks like a single screen buffer being used with a character set at 5000, which is in hex, and that's the character set for the score panel. The characters with the score panel seem to be in the same single buffer as the rest of the game screen as well. We have another character set there at 4800, looks like the character set for the level data, and there we go. We go into the level and we can immediately see that that's the level character set there. We can see that the animating torches are animating in that single buffered screen as well. There don't seem to be any other screens in that big bank. If I extend the memory view over and then let's just check, there don't seem to be any reads or writes for the color RAM memory either, so let's shrink that back down again. I'm intrigued about these long green reads. These are long green reads which are happening consistently every frame. Let's look at these in more detail. There seems to be one long green read for this many number of bytes almost every page. Let's calculate the difference between these. So this is at 2590. If I move left and right, you see, in the level, the green read indicator moves left and right as well. And then if I move down here, then we don't get any green reading anymore in this area of the what looks like map data, right? There aren't too many reasons why the game would want to be reading that many number of bytes when you move the game map left and right when you scroll around, right? So let's calculate the difference between the right-hand edge of these. I think that will give us the map width. But if I change the byte there at 2590 and then scroll over, is that a different map block that comes up? Let's scroll to the left again and then let's scroll to the right. I think that's a different map block that's just appeared there. Look, I'm standing on a new map block. Oh, that's interesting. Okay, so that's almost certainly map data, isn't it? That was lucky to find that straight away. Let's change it so this is a different value. So it's from 2 to 1. I think we've got a couple of different variations for map blocks. Let's change it to, I don't know, 6. Let's see what we get. Ah, look, that map block now, which was a solid block, seems to have changed into what looks like a ladder. So let's calculate the difference, the delta between these two values for the rightmost byte being read there. So the first one was at 2594 in hex in memory, and then the second one is at 24C4, so we'll subtract that, and that's D0 bytes, so 208 bytes in decimal. I think the map is 208 blocks. Now, it's usual, very common in fact, to find these kind of games using a map block tile based system. So the maps are comprised of blocks which are, say for example, 3x3 or 4x4 character cells, and then each tile or block is then referenced by at least a byte in the map. So changing that to be 6, let's change that to 6, and there we go. We've got another new map block there, which now is changed from a solid map block, I think it was, to a ladder, right? So block number 6 seems to be a ladder. That's going to be useful information for us to use later on, right? Let's have a look at the memory view. Let's open up a new memory view and have a look in a higher level overview. There we go, you see, look. So we've got these green horizontal bands being read, and then we've got a whole bunch of extra data up above it as well being read, but that's got a different memory read pattern. I really do have a suspicion that that's going to be map tile data or block data. I don't think we have any other. Let's just check the size of these blocks. Okay, the blocks on the map seem to be 4x4 character cells. We can see there, look, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. That seems to be a hand-drawn block with ascending character values, right? And there don't seem to be any repeated characters, at least in that block. Just using the emulator functionality to save a full memory snapshot of the Commodore 64, and then we can load up that snapshot in Charpad and see if we can see if we can extract the map data. Here we are in Charpad, and let's open up. Well, first of all, let's change it so that tiles are enabled and that we've got 4x4 tiles. Let's shrink down the views here so that we can see more data, which is going to be useful later on when we're scrolling through memory. So we want at least 256 tiles. We want a map with width of at least 208. Oh, come on, there we go. And we'll put the height at 64. That's just a guess, but it should allow more than enough data to be visible when we're scrolling through memory to see if we can find something which looks sensible. Now I'm hoping that the blocks, tiles, map data are going to be oriented from top left to bottom right in ascending memory range. So now that we have these windows how we want them, so we can actually see the data in memory when we extract from the snapshot, let's open the snapshot. I think the map is per map color style, so that we don't need to change that. So let's change the character set first. We know where the character set is. The character set was at 4,800 in hex. Now we're looking for the tiles. Now we think that the tiles are low down in memory, and if we have a look here, there we go. We actually have a tile, block tile, with a vertical ladder. So let's scroll that up in terms of memory until we know that the ladder is the sixth, 0, 1, 2, 3, 4, 5, 6, so seventh tile. Okay, and now we've got map width. Now we just have to scroll through the memory for what looks like map data. So let's look just after the tile set memory. So let's move all the way up to 1F00 because it very handily, usefully tells us the end of memory for the tile data, right? And then we can, there we go, there's the map data. And that was very quick and simple and easy. So let's try and get the right colors, or at least some sensible colors, so that the map data looks interesting. So here we go. So we know from the debug, C64 debug GUI, we know actually that the background is using green, and we know that the character color is multicolored black. This means that we can use, it's kind of like an inverted display, a bit like what was used in the Armalite title screen and in-game screen. It means that you can use more variations of color if you're not worried about scrolling the color around, which this game is not. It means that you get to choose colors from anywhere in the palette rather than just the first 8 colors for the multicolor character set. So that's why this game uses that technique. It's actually easier to then fade in and out the values because you just have to alter one register rather than altering the whole of color RAM when you want to fade the screen. So we now see that we've got a whole bunch of tile data. There are some unused tiles at the end as well, which is useful information to know, isn't it? But here we are, we've basically got the whole map. The map is not 64 tiles high. The map looks like it is 40 tiles high, so we'll change the map dimensions to be 40. It was 40, right? Yes, there we go. Three lines, map tile, blocks, tiles at the bottom. There we go. So that's the full dimensions of the map. 208 tiles horizontally and 40 tiles vertically. And now we can use Sharpad to zoom around all of the map data and we can have a look at the whole map. I'm going to save this working file as a CTM file in the debugging details directory along with the debugging notes and everything else for this game as per usual, and I will put a link to that in the video video description below. Back in ICU 64, if I zoom into the character set being used, we can see that we've got some dynamically updating character set definitions for the water, probably the flames, and the little spikes things that come up in the top there. We have a whole ton of sprites actually in this Vic Bank as well. Let's zoom into that to make it a little bit easier to see. So yeah, this game uses a whole bunch of sprites. The swinging ropes left to right are obviously using sprites. We can see the sprites up in the top of the sprite definitions there. Seems to be using at least one screen's worth of information, right? That's probably why this game is using a single bank, is that it doesn't need to use a double buffered screen, so actually it can use a whole bunch of extra sprites for that. The biggest sprite object in this game is probably this elephant. I quite like this graphic. Just a little shout out for that one there. Pay close attention to the sprites when going back to the title screen. There we go, we've got the sprites for the logo appearing there, and then they get swapped over with the sprites at the end of the graphics map in memory there. So those 8 sprites get copied over when going backwards and forwards between the title screen and the game. There we go. I don't think there's anything else too much in this game that I want to cover. A nice short and sweet video. So if you like these kind of deep technical dives into Commodore 64 retro games, then please do consider liking or subscribing to my channel, and I hope to catch you around next time. Have a great day, evening or night, wherever you are.